So to begin with the midterm exam, the first sort of question expects you to use the RDS service as well as the Elastic Cache service of AWS to set up the MySQL and Redis instances. So for RDS, which is the MySQL instance, first you have to create the subnet group. So I'll just go to my subnet groups. Here is my MySQL subnet, and the question specifically asks you to create two private subnets across two AZs. So as you can see, I've done that, and these are across two AZs. And the setting up part for the MySQL instance is pretty straightforward. The instructions are already given here, so I already have that set up over here. And one thing that sort of needs to be taken care of is that when you actually select your version and then you go on to enable this particular option, it sort of sometimes removes this version and changes it to something else. And then when you actually end up making the MySQL instance and when you are trying to connect to it, there can be some issues. So it's important to just go back, scroll back, and just see if the version is correct or not. I think all the other steps are pretty straightforward. The DB user, DB password, CMP281 VPC, and next what I tried to do was uh, create a Redis instance, and for this also the initial steps are pretty straightforward, and here it sort of asks us to create a new subnet group called Redis and also create a new security group with the Redis port open. So I think I've done that in my AWS, showing the 6379 port open. And once you have done both these things, it's sort of time to make the jump box instance. So I used a Amazon Linux image for making the jump box instance, and I'll just go over to that. So yeah, that's my jump box instance with its public IP. And if you see here, it sort of asks us to SSH into the jump box and then sort of install the MySQL client to connect. So what you have to do here is that once you're done with these two steps, the host will be the host like this, like it's been given in the link that was mentioned in the exam. So this particular endpoint is your, if you go to your MySQL instance and if you go to the connect parameter, so this is the endpoint that you have to use. So what it will actually transform into is, it will transform into MySQL u admin, which is the username, p h, and the host name, which is the endpoint. Once you do that, you have to enter the password midterm 281, and if everything that you have done is right, then you are able to shell into your MySQL instance. And similarly for Redis, you have to do these steps, which are pretty straightforward, and then again use this particular command. And again for Redis, the host will be the endpoint, as you can see here, my Redis cluster being set up. So if you see here, the host is the endpoint over here. So that is what we have to do here. And for the submission part, you just have to navigate to the Redis dashboard as well as the instances details of the MySQL and Redis. So I I sort of do have that submitted in my submissions, so that's pretty self-explanatory. And also for these commands, like as I'd mentioned before, that once you sort of uh, shell into your MySQL, you sort of have to create a database schema and add the gumball table, the schema, and then insert some data into it. And for Redis, you just have to check if there are any keys or not, or what is the list, what is the number of the keys that are being returned. So we are sort of expecting it to return an empty list, and we'll come to this particular portion later. So once you have done all this, the second part sort of expects you to deploy a gumball cluster with an internal ELB. So what you have to do here is you have to create two Amazon instances, the EC2 instances, as I've as I'm showing here, Gumball 1 and Gumball 2. So in the interest of time, what I've done is I have sort of taken my code for Gumball. So if I go to, okay, maybe it's here. So this is the Gumball code that you have, right? So what I've done is I have just used SCP and transferred my Gumball folder entirely into my EC2 instance, which I'm showing over here. And I have tried to build the code inside the Go using the build command, and I've subsequently created that image inside, and then I have created the container as well. So once you have done that, and once you have created the container, and you are sort of able to SCP into your uh, into your EC2 instance, you can always check your connections by pinging it from the Jumpbox instance to see if the connections or if these commands are sort of working properly or not. So one thing that you have to sort of remember here is that when you're even doing the SCP to transfer the Gumball file, you have to do it via the Jumball instance. That is, you have to transfer it first to the Jumpbox instance, and then you have to shell into the Gumball instance, this one, from this to into this, to sort of transfer the file. The reason we do this is because the two instances that we'll create are part of a private network, so they are not sort of accessible publicly. So that's important that your entry point to these instances is only the jump box. So once you have done that, and once you have made all the connections, checked everything, you sort of have to run these commands. So what this is doing here, I think this will be sort of more clear if I open my screenshots. So I can sort of just go to my question 2 command. Yes. So if I go over here, so yeah, as you can see, it's the MySQL count here is sort of not changing. Like, even though we have run the commands, so this is actually just a basic ping command, and this is basically going to give you the machine inventory. uh, this is going to place an order, and this is going to process that order. So what we ideally should expect here is that this count gets reduced by 1, but as you can see, it's 1000, which was the original count. And for Redis, when you try to do this particular step, so what it sort of shows here is it returns a key, and when I do get that key, it returns order process. So what we sort of understand from this is that maybe the server.go file doesn't have the code to update the SQL MySQL database. That's why this count hasn't changed. And for Redis, it what it means is that the key is sort of is basically going to return a list, which is going to return the frequency of the number of orders that have been processed. So that was the purpose of doing this. And yes, so another thing that we have to do is that once you are only sort of doing all this, even these particular steps that I mentioned about, once you have created your EC2 instances, you sort of have to put these two behind the elastic load balancer that we can use in AWS. And what I also did was, just to save time, was that once I created one particular EC2 instance, which is this one, and once I was sure that the program got built properly and the container was running fine, I just made a exact image out of it so that I don't have to do the same steps again. And yes, so I was talking about uh, putting this behind an internal elastic load balancer. So what this step sort of expects you to do is that once when you create the elastic load balancer, there is an option for you to select to create it inside, and there is one ELB port and one instance port. So what you have to do is that the instance port will be 3000 because that's what the code defines, and the ELB port will be 8080 because that's what I have taken. So that's the way you have to do it. So what you need to be careful of is that when you actually run this particular command, as you can see, yeah. So I think I'm doing a post command here, which is you're placing an order. So if you see, I'm actually hitting on 8080/order. So, and the host is the public DNS of my ELB. So I'll just go here. So if I go to my load balancer, okay. So if you see, this is the DNS that we have to use there, and I'm hitting it at 8080 because what we need to check is if the end at the ELB, the port that's exposed for the ELB, that is working. So when you actually hit that particular port, it's going to route internally into the 3000 uh, API and sort of place the order. So that has to be sort of kept in mind while doing that, because if you don't do that, there will be some issues. And one more thing, what you have to do is that when you actually set up your health check, so by default it's set to /index.index.html. You need to sort of change the port. The port is 80 by default. You need to change it to 3000 slash ping, because that's where the Gumball app is going to listen. So this needs to be done, otherwise they will never come in service. So that's one key thing that you have to remember. Now going on to, so yeah, this sort of asks you to submit the curl commands, the MySQL Redis entries, and the reason for the update. So if you go to the third part now, uh, this sort of asks you to deploy a Kong API gateway on a publicly facing Docker host. So for this, what I did was that in one of our labs, we were asked to sort of create one Docker host for the Starbucks API. So that's my Docker host. So this sort of uses a CentOS image, and then you sort of install Docker. So we actually have the steps over here. So this is what professor had given us. So I sort of use this as my base image, and if I go here, so that was already ready. So I just had to sort of uh, you know run my Kong API with a docker run command. It's pretty straightforward. So first running the database, then the Kong all over it. So what you have to be careful here is that while running these commands, it's important to remember that uh, the the container will only start properly if both the database and the container are defined in one network. So first you have to sort of create one network. So I was sort of making this mistake, and I wasn't understanding why it was getting shut down. So by after making 2 3 attempts, I sort of realized that I wasn't sort of making one network first and adding these two there. That's why that was happening. So that's something that needs to be kept in mind. And for this particular step, this is actually routing the Kong to the internal Gumball ELB as an upstream API. So what we do over here is, I think it's better if I sort of go to my screenshots. Yes, so this is just the run command that I was talking about previously. So as you can see here, you have to sort of create the Gumball network, and then only you have the Kong API running. So yeah, to configure this, you sort of need to uh, make a post command. And as you can see, the upstream URL that I'm using here, this is the DNS, public DNS of the ELB, and this is the 8080 port it will it sort of listens to. So, and the API name is Go API, the reference path. So what this is going to do is, uh, yes, so this is sort of going to change into uh, HTTP. This will change into your Kong API gateway. So your Kong is currently on the Docker host. So the public IP. So you'll have to hit the public IP. That will now be your host. That's where, because that's where Kong is. So you sort of have to hit that, and you will have another reference path of Go API, and whatever you sort of follow with your Go API, whatever resource name follows to with Go API, uh, that sort of gets added to this upstream URL that we have for the ELB. So just to explain it better, if we take an example over here, uh, yeah. So for example, if I'm talking about a simple ping on my local host, it goes to localhost 3000 ping. But if I'm talking about an API, the Go API reference that I have added, that for APIs that go via Go. So if you see this, this is sort of the IP of the Docker host. This is where it's sort of listening at. Now this is the Go API, and this is the ping that we have. So everything is getting routed through the Go API. Even if you look at some other examples, say for example, look at get machine inventory. So this is just straight localhost 3000 gumball. And if I look at the Kong, it's Go API gumball. So everything gets, so practically what happens is that whatever gets added after this, that gets added to your upstream URL. So that's what we were sort of asked here to do. And apart from all these steps, we are also sort of asked to add an authentication key to the Kong API. So the way we have done that is, again, using the terminal and using curl to make these post commands. So this particular command is sort of adding the API key plugin first. And once you do that, you sort of need to make an API client, which I have done here. So the username is the API client, and then you need to add the key to the API client, which I have done here. So this is the key. So what you need to do is you need to sort of store this key somewhere, because when you actually run commands, say for example, if I want to ping my Go API via the Kong gateway, so obviously I'll be using Go API ping, but now I'll have to include the API key in my header, because now we have added that authentication. uh Before, I did not have to do that. I did not have to add any key in my header because there was no authentication. But now, because you have authentication and it's required, you need to add that unique key. Otherwise, the API won't run. Similarly, for machine entry, again, you can see the API key over here and the result here after you've placed an order. So when you want to actually process this order, you need the ID, because the API has been written in a way that it sort of expects you to add the ID, the order ID, that is. If you can see here, it sort of expects you to add the order ID. So that's what we have done, and it returns a message of order being processed. So that sort of completes the part 3. If we move on to part 4, so part 4 is relatively simpler. It sort of expects you to modify and deploy the Node.js on a local Docker instance. So in fact, coming to modification, there was one more modification that we were sort of required to do. So I'll just go over to that part. So if I go to Gumball, I go to source, go to Gumball, go to server go. Yes, so if you see this, this was given as the username as root and CMP281 as the password. So when you are actually using this file to connect, to ensure that it connects to your MySQL and Redis instance, you sort of need to change this. So this is going to become your host, which is the endpoint which I was discussing about earlier. So this is the endpoint I was talking about. So you have to make that change here. Here this will become admin, because that's what we have defined over here. And similarly, password will be midterm 281, and this is going to be the same as the endpoint for the MySQL instance that you have up on RDS, and the schema name was CMP281, so this doesn't need to change. So this was also supposed to be changed. So that's one point that I wanted to cover. And coming back to the Node.js part, so you actually need to modify the Node.js code for this as well, because if you see, uh, we are expected to point it to the AWS Kong API gateway. So what we need to do here is, if I go to my Gumball, this is my Node.js, yeah. So yes, so this is, if as you can see, Kong endpoint, the order endpoint, and the API key. So the API key will now change to the API key that you got for your particular order that we are discussing about earlier, and this is going to change to your public IP of your Docker host, which is this. And yeah, this sort of pretty much remains the same, because that this is what we need, the API reference path. So this is going to route it to the Go app that we have running. And yeah, so these three are the changes that you need to make. And once you do that, it's the simple basic step of building, as well as first the image. So I'll just go to those steps. So yeah, docker build t app.js. Once you enter into the Node.js folder, so that's going to create your image, and this sort of downloads one Node Carbon image alongside as a base image, just like when you actually build Go programs, Golang image is added. And after you do that, you need to sort of start the container, right? You need to run the container. So what I've done here is the app is sort of listening at 8080. So if I go to the app.js file, you can see it's listening at 8080. So I have sort of added, like I'm mapping it to 8181 on my local machine, and this creates my container named node.js. And when I actually run that, when I hit 8181 on localhost, I get my app, right? And you insert it, it now has a coin, as the app says. And when you turn the crank, you have your order ID and the status as order being placed. So this is what we were asked to sort of test, and this is what we were sort of asked to submit. And the fifth part just sort of expects you to submit your upload your source code, just make a zip file and submit. So I've already talked about the changes, and that sort of takes care of the whole lab. So what I've sort of understood from this is that if you just directly concentrate too much on the architecture of it, it sort of looks a bit daunting. But if you follow the steps properly, make proper mappings, add everything in the proper security group, uh, with some effort, you are sort of able to finish it. So yeah, that's about it.